Good morning, students. Dear students, first of all, heartiest congratulations to you all for your board results and wishing for your bright future. As I am uploading daily lecture videos, two or three topics daily. You must have to watch these videos regularly to get the sound concept, sound knowledge regarding that topic. So you have to watch that videos and practice for the questions, what questions we used to attempt in that video lectures. So students, today we will start our discussion with the Galileo's law of odd number. As you are knowing that we are continuing with chapter 3, motion in a straight line, and in the same topic, in the same chapter, we are discussing with Galileo's law of odd numbers. Galileo's law of odd numbers. Yes, students, Galileo was the first scientist who made quantitative studies of the body or the motion of body under free fall. This law deals with quantitative study of motion of object under free fall. It means to say that what if an object is falling freely. Suppose I am saying that here there is a stone is falling from here to the ground, and if this stone is falling freely from this top of the building to the ground, then if we divide this time interval in t successive intervals, t, suppose I am giving it the tau, 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 tau. We had divided the total interval from falling of the ball from the top of the building to the ground into tau subsequent time interval equal time intervals. So the displacement covered by this ball in these time intervals are in the ratio 1 is to 3 is to 5 is to 7 is to 9. Means what the displacement covered by this ball in this time interval, in this time interval, in this time interval, in this time interval, in this time, all these time intervals, the displacement ratio of displacement covered by the ball has the ratio 1 is to 3 is to 5 is to 7. So first of all, we will discuss about the law and then we will discuss for its proof. Look at here, students. This law states that the distance traversed by traversed by a freely falling body during equal intervals of time stand to one another in the same ratio, that is 1 is to 3 is to 5 is to 7 or to 7. Okay students, so this is the statement of Galileo's law of odd numbers. Now we will discuss about the proof for this Galileo law of odd numbers. So look for the proof. First of all, we divide the time interval of motion of an object. Divide time interval for motion of the object, into many equal intervals tau. We are divided into equal intervals tau. Since initial velocity u is equal to 0, since the object is falling from here, if the object is falling from here to here, u is equal to initial velocity is equal to 0, then the distance covered y is given by s is equal to ut plus half at square. So you can give it as ut is 0 minus half gt square, Now we have to calculate the position of the object at different time intervals. Calculate the position of the object it will be u is equal to half gt square, only half gt square, because it is the motion is not upside down, it is in downward direction, so half gt square. Calculate the position of the object after different time interval. We have to calculate the position of the object after different time intervals, and for this I am going to make a table. Here I am writing t, here y distance traveled, y in terms of y naught is equal to half gt square, distance traversed means traveled in successive interval. Distance traveled in successive interval, ratio of distance traveled, ratio of distance traveled, ratio of distance traveled. So when t is equal to 0, there is no distance traveled, y is equal to 0, and y naught it is equal to 0. And distance traveled successive, so before this there is no any distance traveled, so it will be nil. Now when the time interval become tau, so y is equal to 1 by 2 g tau square, t is equal to t, so tau square, and this is equal to y naught, because y naught is equal to half g tau square. Distance it is also y naught, and the ratio is equal to 1. The ratio is equal to 1. Second is 2 tau. It will be equal to 4 t square. The 2 square 4 half g tau square, that is 4 y naught. Now the distance traveled, y naught minus 0, y naught, 4 y naught minus y naught, 3 y naught, and ratio is 3 tau, that is 9 half g tau square, 9 y naught. Now look at here, 9 y naught minus 4, that is equal to 5 y naught, and the ratio is 5. Similarly 4 tau, it is equal to 16 half g tau square, and it is equal to 16 y naught. Then it becomes 7 y naught. This minus this 7, ratio is 7. So look here, students. What you are getting? The ratios are 1:3:5:7 up to so on. So this is the proof that the distances are in the simple ratio. The distances are, if we are taking the ratio of the distances are in the simple ratio 1:3:5:7, and this is the Galileo's law for odd numbers. Clear, students? We had, first of all, we had calculated the distance, and after that we had calculated the distance traveled in successive time intervals, and after that we had taken the ratios, and we had got the ratio 1:3:5:7, and this is the proof for Galileo law of odd numbers. So now we are moving towards the next topic, that is stopping distance. Stopping distance for a vehicle. The stopping distance for a vehicle. A stopping distance for a vehicle. What is the meaning of a stopping distance for a vehicle? It simply means that when brake is applied to a moving vehicle, when you are moving a vehicle, suppose here there is a vehicle, there is a car, and car is moving, and you had applied brake. So as you will apply the brake on the vehicle to stop the vehicle, so the car, before coming to the rest, it will travel certain distance x. So whatever the distance covered by the vehicle after the application of brake and the vehicle becoming stop or taking halt, that distance is called as the stopping distance. This distance is called as a stopping. This distance is called as, or stopping. This distance is called as a stopping distance. So first of all, we will define a stopping distance. After that, we will derive the formula related to stopping distance and then solve a numerical based on this. So when brake is applied, when brakes are applied, brakes are applied to a moving vehicle, the distance it travels, the distance it travels before coming to rest is called stopping, stopping distance. That distance is called as stopping distance. Now we will calculate the stopping distance for a vehicle. Let distance traveled by a vehicle before coming to rest is ds. So using the equation v square is equal to u square plus 2ax, since finally the object is going at rest, finally the vehicle is coming at rest, so the final velocity v is equal to 0, and we had supposed that it had traveled a distance of ds, so x is equal to what? X is equal to ds. X is equal to ds. So a stopping distance ds, a stopping distance ds, a stopping distance ds, it can be given as ds is equal to, this will be equal to 0, so it becomes minus u square upon 2a, minus u square upon 2a. Now look at here, students, the stopping distance is depending upon two factors. The two factors is that with what speed the vehicle is moving, what is the speed of the vehicle when it is moving, what is the speed of the vehicle, and what is the quality of your brake, what is the quality of your braking system. These two things decides the stopping distance of the vehicle. Now here you are seeing that the stopping distance ds is directly proportional to u square, directly proportional to u square, means if u is doubled, if suppose the object is moving with 20 meter per second, initial velocity is 20 meter per second, and if you had doubled the initial velocity to 40 meter per second, then the stopping distance becomes 4 times, ds became 4 times, the stopping distance becomes 4 times for the same acceleration. For the same acceleration, the stopping distance becomes 4 times. So let us solve a numerical based on this. Now dear students, look at the numerical. Here the numerical says that a car is moving with a speed of 50 km per hour, can be stopped by applying brake after covering a distance of 6 meters. means when the car covered a distance of 6 meters, then the driver of the car applied the brake. What will be the minimum stopping distance if the same car is moving at the speed of 100 kilometer? If the car is moving with 50 kilometer, then a stopping distance is 6 meter. And if it is moving with 100 kilometer per hour, then what will be the stopping distance? So here in the given question, the acceleration is not given. Anywhere acceleration is not given. So in the first case, from the given details, we can calculate the acceleration or retardation of the given car, and on the basis of that retardation we can calculate the stopping distance for the second case. So look at the solution. Solution for first case. It is given u is equal to 50 kilometer per hour, that is 50 into 5 upon 18 meter per second, and it is equal to 125 upon 9 meter per second. Now v is equal to 0 and x is equal to 6 meter. From this data we can calculate the acceleration, that is v square minus u square is equal to 2ax, or you can say that 0 square minus u square is equal to 2a into 6 meter, and it can be written as a is equal to minus 125 into 125 upon 81 into 2 into 6, because u square, so 125, 9 9 81, 125 into 2 into 6, and on solving it you will get minus 16.27 meter per second square, and it is acceleration is approximately equal to minus 16 meter per second square. This is the value of acceleration. Now based on this acceleration we can calculate, or you can directly, if you have got the acceleration, then you can directly calculate the stopping distance for the second case based on the formula. The stopping distance for the second case. Stop case second. If the initial speed becomes 100 meter per second, then the stopping distance ds is equal to minus u square upon 2a, and it is equal to u become what, 100. So change 100 kilometer per hour, 100 kilometer per hour into meter per second. So u is equal to 100 kilometer per hour. So 100 into 5 upon 18 meter per second. 59, yeah, that is equal to 250 upon 81 meter per second. And from here ds stopping distance is equal to 250 into 250 upon 81 into 2 into 60, and this is equal to 24.1 moment. So we had directly, if we had got the acceleration, then we had directly used the formula for a stopping distance, and then for 100 meter per second you had calculated, look at here, for 50 it was 6 meter, and now for 100, look at here, it will be 4 times, 6 4 ja 24. Clear, students? So this is the numerical based on stopping distance. Now the next topic we are going to discuss, that is reaction time. Reaction time. Reaction means if there is an action on you, then how you react for that action. That is reaction time. So reaction time means what? Reaction time, suppose you are driving the vehicle, and suddenly a boy comes in the front of your vehicle, then how much time you will take to apply the brake, to think, observe, think, and then act. Whatever the time required to observe the situation, to think over the situation, and then to act over the situation, that thing is called as a reaction time. So reaction time is defined as a reaction time is defined as the time a person takes to observe So students, reaction time is defined as the time a person takes to observe, think, and act over a given situation or a given problem, and it depends on an individual presence of mind, and second one, the complexity of situation. So reaction time depends upon what is the presence of mind and how complex the situation is. So suppose I am saying that a normal person can react more quickly as compared to a ill person or a disturbed person or a drunken person. The reaction time for a drunken person or psychological person is more as compared to the normal person. And if there is a very complex situation, a very rigorous situation in front of the person, then also the reaction time increases. So we have to solve a numerical for the calculation of reaction time. A situation is given to you, and for that situation you have to calculate, you have to find out the reaction time for that person. Look at that numerical. Yes, dear students, now the question is in front of you. A situation is given to you, and based on this situation, you have to calculate the reaction time. What was the situation? What is the situation? Suppose your friend is holding a long rod vertically, just like that, vertically, in the gap between the thumb and the forefinger vertically, he had held it just like the rod. He has to drop the rod. Now he had dropped the rod, and you have to catch and hold the falling rod. He had dropped the rod and he had hold the rod, falling rod. If the rod is caught after moving a distance of 0.2, when in releasing the rod and catching the rod, the distance traveled by the rod is 0.21 meter. Now we have to calculate the reaction time. You have to calculate the reaction time for this. Look at the students. Here, the distance traveled x is given that 0.21 meter. If we had suppose t is equal to reaction time, t is equal to reaction time, then x is equal to ut plus half gt square. Since it is the case of free fall, so g we will take, and it has released from rest, so u is equal to 0. So 0.21 is equal to 0 plus 1 by 2 into 9.8 into t square, and from here we can calculate the value of t, and t is equal to 2 into 0.21 upon 9.8 whole under root, and thus reaction time becomes 0.2. So a reaction time 0.2 second. Reaction time is 0.2 second. Okay students, clear? So this is all about the today's discussion. Now in the next video we will discuss about the relative velocity and the cases based on the relative velocity, and after that numericals based on the relative velocity. So that's all for today students. Thank you, have a nice day and take care.